Hello everyone, welcome back to my channel Maths with Smart Tips. Today in this video we are going to discuss the basic definitions of a random variable and the two types of random variable, the discrete random variable and the continuous random variable, and the probability mass functions, definition, simple definition of probability mass functions and probability density function, that is PDF. Now let's start the video, and before starting the video I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. So let us come to the definition of random variable. The definition of random variable says that a random variable is a function x is let us take some variable omega with a domain s. What is this? Let us come to next, and the range minus infinity such that for every real number a, the event omega, this is an event omega such that x omega is less equal to a, this belongs to B, where this a is sample space or the space of outcomes and the B is some sigma algebra. Now this definition you can say some complex definition, but this is the complete definition of random variable. This is some mathematical definition, but for simple use you can just use from this. A random variable is a function x omega which the domain is x, that is the sample space is the domain, and the range is minus infinity. That means you can simply define a random variable x omega. This is a function from the sample space to the real line, that is minus infinity to infinity, that is R. Now the random variables are basically two types. So first one is the discrete random variables and the second one is continuous random variables. We all know that. So discrete random variable and continuous random variable. Now let us come to the point of discrete random variable. The basic definition of discrete random variable, it says that a variable that can assumes only a countable number of real values. That means a real valued function defined on a discrete sample space. That means the sample space S must be discrete. That means if we can say that this S contains the countable number of values. If the S contains the countable number of values and take only the countable number, then it is called the discrete random variable. Now let us come to the definition of probability mass function, that is PMF, which is based on discrete random variable. So the definition like this: if x is a discrete random variable with distinct values, suppose x1, x2 and so on, xn and so on, then the function, suppose px, defined as pxx, this is equal to probability x at the point xi. These are the distinct values, probability at some distinct value. This is equal to let us take pi for x equal to xi. This is the definition of probability mass function, but well known. But these two conditions are well known for the probability mass function. If we want to check whether a function is probability mass functions or not, then we use these two conditions. The first condition is the non-negativity conditions of each of the values, the probability function of at each of the values. So these are the non-negative for all I, and the total probability, that is the probability at all the points, sum of the probabilities, this is equal to 1. So these two are the leading properties for the stands for the probability mass function. Now let us come to the probability continuous random variable. The another one, the random variable x is said to be continuous if it can takes all the values. That means what are the values? Integral values and fractional values. So the continuous random variable takes integral values and fractional values, but the discrete random variable takes only the integral values. It can't take the fractional values. This is the main difference between the discrete random variable and continuous random variable. That is the discrete random variable can takes only the integral values, and the continuous random variable takes both the integral and fractional values. Now let us come to the definition probability density function. So the probability density function stands for probability density functions of a random variable x. This is clearly based on continuous random variable x denoted by fxx or fx, defined by the first condition is each fx is non-negative, first condition, that is fx greater or equal to 0, and the total integration over whole the range, that is minus infinity to infinity, this is equal to clearly 1. So the first conditions for probability mass functions and probability functions, density function, both satisfies the non-negativity condition, and the second one is in case of probability mass function, it is summation form I equal to 1 to infinity, and in case of density function, this is the integral form. Since this summation can include only the integral part, and this integration can take all the parts, that is integral part and fractional part. So this is the main difference between probability main function mass function and probability density function. Now let us come to an important note. Based on this note, the most of the questions like GATE, session, NET, the IIT JAM question comes on based on this point. The question, the note says that in case of discrete random variable, the probability at a point suppose C, the probability at x equal to c is not equal to 0 for some fixed c. This is the case of discrete random variable. But in case of continuous random variable, the probability at a point c is always 0. That means probability at a point x equal to c, this is equal to 0 for all possible values of c. So this is the you can check whether for a given random variable, you can check whether it is discrete or continuous, and for also for given distribution function, you can check also the whether it is discrete random variable or it is continuous case. So this is the content for this video. So if this video is helpful for you, then please give a like to this video, share with your friends, and subscribe the channel. Thank you friends, and in the next video I will discuss the distribution functions on random variables and their properties of distribution functions.